Hello. In this new episode, we're going to try to together discuss the information design problem and further to try to understand how this incomplete information game is reformulated in the context of information design for the original Bayesian persuasion problem. Okay, and later shortly we'll see how do we use this sort of the Bayesian correlated equilibrium to try to simplify or to alternatively study the Bayesian Nash equilibrium. So and we will also see that the the interesting results and the convenience that brings us. Okay, so now let's get started. And so this is a continuation from the previous episode, and recall that our incomplete information game has the following structure. So the basic game G, it has some basic ingredients. So the action AI, okay, so there are I players, right? So here we have one information designer, which is outside of this game, so it's not counted toward the I's. But here the I's simply include the receivers, right? Sort of the decision makers. So AI is the action set, and UI is the utilities. So those I in the set of I for all the players, and the state space and the prior. Okay, so that's the basic game. and and yeah, as we mentioned, so this is also uh, continues from the Bergemann and Morris 2019 paper. Okay, as we mentioned before. So the information structure includes the signal realization SI. Okay, same from I, and the signal itself, right? Pi. Okay, so this G and T together is it defines an incomplete information game together, right? So, and this is something we already know previously, right? It's from the last episode. So in this new video, we'll try to have something more, okay, on this to talk about the Bayesian Nash equilibrium and also the some another solution concept which is related to this. Okay. All right. So let's do that. So given this G and T, given this game with the incomplete information, so a strategy of player I, okay, we can write this strategy of player I, okay, is sigma I, okay, which is a map from Si to data AI, okay. So this means that this sigma I AI given Si, it's just a probability, right, of taking AI given after receiving the Si, right? So that's pretty straightforward. Okay, so a strategy profile includes all the strategies, right? So that's what strategy profile means. Strategy profile sigma includes all the sigma i's, okay? And this is a Bayesian Nash equilibrium of G and T, okay? If for all i's and all si's, we have sigma I is a positive number, right? With the positive probability of playing such strategy. Okay, good. So specifically, essentially by having a Bayesian-Nash equilibrium, so the action that player I is taking must yield a higher or the same, so weakly higher the expected utility for this player I, right? Greater than the expected utility induced from another action, which is just a deviation, right? So, so that's a unilateral deviation. So that's that's the definition for this solution concept. So specifically, we can write that inequality as follows. So pi is the probability of sending this signal, right? So it has, let's say, Si for the for the signalization received for player I, and S minus I for the other player. Okay, minus I, and omega is the state. Okay, so this probability, and it has to be multiplied by the utility, right? Also, we have the strategy, so we need to multiply all those strategies together, actually, right? And overall, we need to, okay, we need to sum over all the S minus I and omega. Okay, so this times the summation over A minus I, okay, and then we multiply. So this is the multiplication. This is not pi. Okay, this is bigger than, looks bigger than the pi and the information structure. Okay, so for the player J, which is not I, okay, we multiply all the sigma J's, AJ given SJ times UI. Okay, it also has A and omega here, right, as the inputs. So AI and A minus I omega. So this together, it has to be greater than or equal to everything the same, but the only difference is the AI part, right? So that's the only difference. So we just copy and paste. Okay, so here we just put a prime here. Okay, this part. So the only difference is here. Okay, just use a black one. Okay. So that's the detail, or that's the definition for this solution concept, right? Okay, and this must be true for all the AI and AI prime in AI. Okay. All right. So this is a definition, and a definition for the BNE toward this incomplete information game, right? So that's pretty straightforward. So now we can use our old example with the judge and prosecutor. The judge is the decision maker, and prosecutor is the information designer. So we use that example again, right? Okay, to show this new social concept that we use this in this episode. So the S includes G and I, right? And remember, we have all those pi's, right? Pi, G, G. pi gi, okay, pi ig pi ii, okay. So small g is the signal that this person is guilty, and small I is innocent, and big G and big I are the state, right? Okay, so we have those numbers, and we don't need to repeat. We can just refer to the previous episode. Okay, so now we can consider this strategy, sigma, right? So such that the sigma is as follows. So the convict, okay, let's just write conv here. So convict given small g is 1, okay. Let's just consider this setting here. And the sigma of acquit given g is 0, right? And correspondingly, if S is small I, then the probability of convict is 0. Otherwise, it's 1, okay? And we will show that this sigma is a BNE, okay? We'll show this is BNE. Okay. Okay, so we first check that. Okay, so sigma convict given small g, this is 1, and is a positive number, right? And then we check the the expected utility, right? So it's simply pi gg u of convict g plus pi gi u of convict I, right? And this is, I can just give you the numbers, and this is 0.3, okay, and this is 1, plus this is 0.3, and this is 0, okay, so it's 0.3. If there's deviation, okay, if the judge takes another action, and let's try to calculate that expected utility. So pi gg, and pi is the same, okay, so this part is the same. So the difference is that here inside of u we have acquit, okay, so here judge is convicting, but here is acquitting, okay, and g of course is the same, and plus pi the same, but here is acquit, okay. So those are the okay, let me just, this is the same, but the black ones are different, okay. This is very straightforward, so let's calculate that. Okay. This is nothing but 0.3 times 0 plus 0.3 times 1, right? Okay. And this is just 0.3 again, okay? So we can see that this 0.3, of course, it's greater than or equal to 0.3, okay? So it satisfies our requirement here, okay? But this is just the first part, and we still need to check the other part, right? Okay, now let's do that. So this is for the sigma small g given convict given small g, right? And let's check the other strategy, which is positive, has a positive probability. So it is just the sigma of acquit given small I, right? So that's 1 as well, and that's positive. So we only need to check the positive terms, right? Because the other terms are 0, so we don't need to care about those things. So for this one, pi ig, okay, n times u quit if the judge listens the advice, and given g, and plus pi ii u acquit I. Okay, so this is 0 times 0 plus this is 0.4 times 1. Okay. Okay, so you must be already familiar with those utilities and the signals, right? So you can just refer to the previous episode for the example. Okay, so this is 0.4. Okay, and basically, essentially, the judge, if the state and this action matches, then the judge has the utility of 1. Otherwise, it's 0. Okay, so that's basically the utility functions for the judge. Okay, all right. But what if there's deviation? Okay, deviation. Let's write that here as well. So there's deviation. Okay, so if there's deviation, then pi g. So it's still the same, but here inside of u is different. So this is a convict. Okay, different. Given g plus pi ii u convict I, right? So here's quit and here's convict. So what is this? This is 0 times 1 plus 0.4, and those numbers are given in the example previously. Okay, times 0. Okay, this is 0, and 0.4 is strictly greater than 0. Okay, so this also satisfies our definition, right? Okay, good. So that's how we verify our example regarding this new solution concept we introduced here as the BNE, right? Okay, so actually the choice of T is the choice of BNE, right? So here actually we wish to talk more about the outcome that we mentioned previously, okay? And we simply, the outcome V, okay, is simply defined as the joint distribution over the state and action. Okay, so that's the outcome that we're going to discuss further. Okay, and later you will find that when we use the outcomes, then it's easier for us to understand or to formulate this information design problem, and we can use another more sort of the simplified solution concept of BCE, base correlated equilibrium, rather than the BNE. Okay, for this problem. Okay, so all right, so here T, okay, the information structure. All right, so we don't need to explicitly write that. So T and sigma together, okay, they induce an outcome. Okay, outcome. Okay, so we just write this as V. Okay, doesn't matter. So, which is a joint distribution over the state and action. Okay, and so specifically it means that, okay, this is given by the summation of all the possible strategies, right? And we need to multiply all those strategies and the corresponding information structure or the corresponding signal, right? And then sum them over all the signals. Okay. So we sum first over all the signals, and we have our pi's, s, and omega. Okay, so here when you do multiply, again, so this is just multiplication, right? So sigma ai given si. Okay, we multiply all those together and then times pi, then sum them all up over all the s's, and then this is our outcome. Okay, and this has to be for all the a's and all the omegas, right? So then the information designer could just choose the V rather than choose a B and E, right? Then it can be just a choice of this V, okay, rather than a B and E, okay. And this is actually called partial implement, okay. So more rigorously, so this V is what we call partially implementable if there exists an information structure T okay, and a BNE of sigma of course of this G and T, right? That induces this V. Okay. Then this is called the partial implementable. So that's just a definition for that. Okay. Okay, now let's go back to our example, and then we try to understand what is V's. What are the V's here in our example, okay? All right, so that's not very hard. So V is just the joint distribution over this omega and A, right? So V convict big G. Okay, so we have all those combinations of the state and the actions, right? So this is nothing but pi ig. This is the joint distribution over the signal and the state, right? And times the sigma convict given I, right? And plus pi gg times sigma convict given little g, okay? And this is just 0 times this is also 0 plus 0.3 times 1, okay? And it's 0.3. Okay. And similarly, we can of course calculate other combinations, acquit and big and I first. So this is 0.3 times 0 plus 0.4 times 1, okay, and it's 0.4. And accordingly, convict given I is 0.3 times 1 plus 0.4 times 0 is 0.3. Okay. And lastly, for the state is G and the action is acquit. Okay, then this is just 0.3 times 1 plus 0 times 1. Okay, this is 0. And we notice that those four numbers together, they add up to 1. So this is a valid joint distribution. Okay. And we can also notice that still we should remember that we have another definition for the information structure, right? That is the marginal distribution of the actually here is it's different. So here we can notice that 0.3 plus 0 is 0.3, so which is the prior of the big G. Okay, and that is also the marginal distribution of the V on the big G, right? Because we sum out or sum over all the actions here, right? Given the state is G, big G. Okay, so that's a very simple, very simple example for us to verify that, right? Okay. So the sigma here, okay, so sigma is BNE, okay, so okay, this V is partially implementable, right? And we have already verified that. So from now on, we cannot only we cannot only use the BNE to study our to make it as our solution concept here, but we can also use another solution concept called base correlated equilibrium, okay, which is concentrating on this V, on the outcomes, rather than the pi's and the sigmas for the previous solution concept of the BNE. Okay, so that's something that perhaps which is more convenient, and we'll show that very soon, shortly. And that would be very helpful for us to make more actually to study more complicated information design problems. Okay. So what is this base correlated equilibrium? Okay. So let's formally define that. Actually, we don't need to originally to define that. We just need to have to connect that to our outcomes, right? So that's enough. That's sufficient for us to study that. So let's do that. So as mentioned in the Bergemann and Morris 2019 paper, so they proved that in their theorems or propositions, so they proved that the V, okay, as a joint distribution over state and action, this is partially implementable if and only if it's a base correlated equilibrium, okay? Okay, and specifically, what does it mean? It means that, so this V, okay, is a BCE, okay, is a BCE of the G, right? Okay, so let's explicitly write that G, AI, UI, all i's, omega, mu naught. Okay, so V is a BCE of G if it satisfies the follows. Satisfies. Okay. So there are two important requirements. So the first of that is consistency. Okay. We see a lot of consistencies in the solution concept definitions, but this consistency is quite different from the one such as the consistency in the sequential equilibrium, right? So those, although they have the same name, but actually they mean different things. So here this consistency, it means that the marginal distribution of the V of the outcome, okay, over the omega, over the state, equals to the prior, okay? And we have seen that previously. And remember that actually our definition for the information structure, an alternative definition for that, right? Remember, it is this kind of definition that is, which was saying that the summation of the marginal distribution of the information structure, or the pi, over all the state equals to the prior, right? Okay, so here we have this consistency requirement. That's pretty similar, but we will mention that later and see some connections. So it's nothing but the summation of the V for this joint distribution for all the A's. So this is nothing but the mu naught of omega, okay, for all the omega, of course. So this is a consistency, okay. And the second one is that obedience, okay. So this obedience is sort of the pretty connected or interpretation of this correlated, right? Correlation. So it's those the receiver or this judge or this decision maker has to be to have this sort of obedience toward the sender or toward the inference designer to achieve this base correlated equilibrium, right? So that's some sort of the meaning or the definition or some background of that. But here, more rigorously, mathematically, so for all the i's, okay, so for all the i's, all the players, but here in our example, we just have one player, one decision maker, right? But here, more generally, we have a lot of i's, right? So that doesn't matter. So the obedience means that the expected utility of listening to the advice or listening to the action recommendation from the information designer, this has to yield a higher or equal expected utility than the case where the decision maker doesn't listen to the advice or doesn't listen to the action recommendation, right? So there will be some deviation in that case. So let's formally write that down. Okay, so the summation of the expected utility, right? So the summation of those terms. So this is over the omega and a minus I. So v of ai, a minus I, omega, ui, ai, a minus I, omega. So this has to be greater than or equal to the case that there's deviation for the sender eye, for the receiver eye, okay? So other terms are the same. So the only difference here is the ai prime, okay? This term. That's it. And this is true for all the ai prime in the set, okay? Good. Now let's try to prove that. Okay. So first is the this direction. Okay. So we first suppose that this V is partially implementable. Is, let's say, pi. Okay, partially implementable. The word is too long. So this V is induced by the information structure T and the BNE sigma. Okay. Then what we need to do is to check those two requirements, right? So let's first check the consistency. Consistency to check. Okay, so for all the omegas, let's just check the summation of the V's, right? So that's what we are going to check. So this is, we just expand those things and plug them in, right? So this is nothing but the, so remember the definition for the V's, right? So this is induced by the T and sigma. So we just write the how do we induce them, right? So we have those formulas previously. So that's pretty simple. So this is pi s omega times this is product, okay? Not pi here. So the big thing here is the product sigma I ai si, okay? So we just exchange the order of the summations, okay? And then we get the follows. S omega, okay. And here inside of bracket here we have the product of the sigmas, okay. All right. And we notice that this is actually 1, right? If we first multiply all those sigmas together and then we sum over all the actions, right? So that's nothing but 1, okay. Then that's pretty straightforward. Then this becomes this, okay. And recall that we have that sort of the definition, right? We just mentioned. So this is the marginal distribution of the pi over the omega. So this is nothing but mu naught, okay, the prior. And that's done for the first check of the consistency. And the next thing to check is the obedience, okay. Obedience, right? Okay. So now here we use the BNE again, right? And to check the expected utilities for the obedience. And we fix the I and AIs or AI prime, okay? So for all the SIs, okay, so we just do this from the BNE and we just make it like make the form sort of the form look like the obedience in the BCE, right? So that's what we're going to do here. So just try to construct that inequality. So what we have in BNE is remember that the pretty long inequality, right, in the BNE for the left hand side is greater than the right hand side, and the expectability for taking that action is higher than or equal to the one with deviation, right? So that's the one that we're going to use here. Okay, so let's do that. We don't need to write it again, but here, just for convenience, I just write it here for you to see this. Okay. Summation of AIs, A minus I's, and the product J, which is not I, sigma J, AJSJ, okay, UI, AI, A minus I, omega. Okay, pretty long. Which is greater than or equal to, okay, I don't want to write it again. Let's just copy and paste. All right. And then the only difference is this. What? Yep. Prime. Okay. This term. Okay. So we multiply both sides by the sigma, okay? Sigma I. And then we sum over the SIs, okay? Then after that, the S minus I's become S, right? For those summations terms, right? Notations. So and after that, the above then becomes the follows. So the summation of S and omega. Okay, so then now S minus I becomes S here. Okay, in this place. So, and for the pi, it's I is minus I omega A minus I. Okay, the product, and here we have this J, right? And because we have the sigma I multiplied, so this also includes I. And J, S, J, UI, I minus I, omega. Okay. And of course, can copy and paste and just change that, add a prime. Okay. That's pretty simple. Okay. Prime here. That's too big. This term. Okay. All right. And then we exchange the order of the submissions. Okay. All right. And then we just do the summation over S and omega, and then the summation of AI here. Okay, so now let's do that. Why not? Okay, Si S minus I omega, and the product of J, it's the same things here. Okay, UI. Okay, and it's also greater than or equal to the same, but adding the prime again. Okay, prime. Okay, differences here. All right. So, and if we can write this, then we can, of course, change those two notations, right? So we can change those two parts, right? So we can write this first and the other later, okay? So we can definitely do that. Okay, so what we are trying to induce from this is the V things, right? Including the V's. So we have to sort of to construct the V's, right? So how do we construct those things? So it's actually we already constructed that, right? But it's just hidden inside of this inequality, right, on the both sides. But maybe you can already see that, right? So let me just make it clearer, and you'll just notice that, okay, from this inequality. So then this becomes a minus I, the summation over a minus I omega, okay. Then if we, okay, write the bracket here, if we put the summation of S inside of this bracket, then the summation of S and then times pi times the product of all the sigmas, then this together becomes the V, right? So that's the trick of this construction. And that's pretty fun, right? Pretty interesting. Okay, so let's do that. So pi Si is minus I omega, this product of the sigmas. Okay, should be just the round bracket. And the UI, okay, outside of that. Okay, so that's greater than or equal to the thing with the prime, right? Let's copy paste. Okay, that's too far. Let me just, okay, all right, good, prime. So this part in the bracket, and in the bracket, those are the V's, right? And we have successively constructed the V's. So let me just write it again. The summation of over omega and a minus i's V a omega ui ai minus I omega is greater than or equal to the same, adding the prime. Okay, just copy and paste here quickly. Okay. All right. So then this satisfies obedience, the requirement of obedience. Okay. So that's a pretty long construction, but yeah, it looks very fun, right? Okay. Now we are going the other direction, right? From the latter to the former part. Okay. So that's just the first part of the proof. Now it's the second part, okay, going in this direction. So now we suppose that V is a BCE, and now we are trying to do what? Now here we are trying to construct the sort of the T and the sigma, which can induce this BCE, right? So remember our goal during the proof, so that we are not going to be lost. So construct a T and sigma, which can just induce a BCE. Okay, so that's our task here, or what we are going to do. So let's just construct a T. So this T includes the SIs and the pi, right? So this T, we just let it to be an action recommendation. Okay. Okay, so it means that in this way, it means that first, the SIs equals to the AIs. Okay, this is for all the i's. And secondly, it means that the pi is the v itself. Okay, so that's how we're constructing that. So as long as we can show that those T and sigma can induce the BCE, then actually then in that case we will have successfully constructed this T and sigma, right? Okay, so specifically for all the i's, so the sigma I is defined as follows. So it's the AI given as i's. So it's either 1 or 0. So it's 1 if AI equals to SI. If not, then it's 0. Okay, so that's a pretty intuitive strategy, and the reason that we're calling this as the action recommendation, right? Okay, so now the next thing, the important part is to show that this T and tau, they can actually induce this V, right? So to show T and tau induce V, okay? So we check the this induce, right? We check the process of inducing that V. So namely, remember that it's just checking the definition of that. So summation of all the s's pi times the product of all the sigmas, right? Remember the definition in the beginning of this part of the V, right? So okay, sigma I, and this is just pi, right? Again, so the other term is 1, then this becomes the pi of a omega, right? And actually, this is because that, so we need sigma to be 1 for everyone, and this is to let everyone have the obedience, right? So that that term is not 0, right? So for all those terms that has a value of 1s, then we sum those terms together. Okay, so actually we're summing all over those s's. Actually, if given those s's, then the sigma here is not 0. Okay, so let's just write some notes here for the obedience. Okay, and we sum up all those pi given positive probability of those sigmas, right? So that's what we're doing here. Okay, so that gives us this pi a omega, and by our definition, so our pi is then defined as the V. Okay, so that's our outcome. Okay, so that's the first part, right? Okay, so we still need to show that the this sigma here, it is the BNE, right? And this is actually, so here this is the first part. Then later we're also showing the relationship between the expected utilities, right? Okay, then we'll use the obedience to derive the BNE, right? Shortly. Okay. So to see that, and we will know this after we write those things formally. So to show that the sigma is the BNE, okay. So for all the i's, we let si equals to ai, okay. So sigma I given ai given si is 1, which is positive greater than 0, okay. All right, so we have the positive probability of those strategies. And then we use the obedience to derive the BNE, okay. Okay, so what we are trying to do here, okay. All right, so we first use the okay, we'll use we'll use the relationship of the obedience, okay, and to try to construct actually reversely or inversely to try to construct the inequality that we're going to need for the BNE. Okay, so here remember the task is that we're going to use the short version of that, so pretty short inequality of that obedience to reversely to derive the longer version of the inequality for the BNE. Okay, so that's what we are going to do here. Okay, so let's first start with the some parts or the from the left hand side or the just one part of the obedience inequality. Okay, now let's do that. Then we'll try to use that to derive the BNE, the inequality for the BNE. Okay, so the summation of s minus I omega pi si minus I omega, and this is summation of all the product of the sigmas times the u, right? So those are just the expected utilities, and this is summation over a minus i's, and this is the product, okay, sigma j, aj, sj, ui, up, yep, okay. All right, so this should be, yeah, this should be ai, right? Up here we can just add the prime here. So this part, this is actually the smaller utility, okay? And later we'll use the other part as the bigger one. Okay, so what is this? Okay. So actually, if we can actually simplify this using the obedience, okay? So it becomes the summation of a minus I omega pi si s minus I omega ui ai prime a minus I omega, okay? So actually we're looking at those terms here, right? So if there's obedience, then it's 1. If there's no obedience, if then otherwise, I mean, we have the obedience, right? If it matches, then this is 1. If it doesn't match, it doesn't match, then this is 0, right? So after that, then we can sum those all over the s's, right? Then actually here what we get is the this result here as follows. Okay, so here we just use obedience, and then we simplify. We actually simplify this, right? Okay, good. So that's the first simplification. Then we, by using obedience, then we can sum over all the s's to get this. Okay, and then we notice that our v is defined as the pi, right? So here we can simply replace this pi as the v. Okay, using the outcome. Okay, so those s becomes the a's, okay, by replacing the pi into the v's. So all the others are the same. Okay. So now we are using the obedience again. And this is the most important step, the most important part is that we're using the actually we're using the obedience inequality here. Okay. This is smaller or greater than the thing without the prime, AI without the prime. Okay. And we can copy and paste that, of course. Do that. Okay. And then we erase this part here. Okay. So this is a different part. All right. So this is just by obedience equality. Okay. All right. So and what we are going to do next is to reversely write all the above parts again, right? But reversely. So it means that we write all those corresponding equalities here as follows, right? Next, and but we write those in terms of the other notation without the prime, right? So that's we're doing here. Okay. So actually, then we can actually skip those parts, right? So basically, we just write those. Yeah, but we can actually do that, of course, which makes this clearer. Okay. So actually, we're doing. So this we just copy and paste this one. Okay. All right, and this is just equals, and we use raise this prime. Okay. And then we copy and paste the first term. Okay. And of course, remember to erase the prime. And this is should be equal, right? Okay, perfect. So from here, we can already see that. All right, you can see that this is less than or equal to this, right? So the first expression is less than or equal to the last one. Okay, and then altogether we can write this explicitly, but yeah, why not? We just do it again. S minus I omega pi I S minus I omega summation A minus I, the product of J sigma J AJ SJ UI ai prime a minus I omega is less than or equal to the same, but erasing the prime, okay, which has no deviation, and it has a higher utility. Okay. And we erase this. Okay.